Hello everyone, welcome to this video. Today we'll be discussing the RMO 2023 problem 4. So this is a geometry problem and although it's very difficult when you see it, it's actually not a very difficult problem. Let's see the problem. Uh, I have the diagram here and so let omega 1 and omega 2 be two intersecting circles with centers O1 and O2 respectively. So these are the two circles as you can see with O1 and O2 as centers. ABCD is a line with ABCD points in that order such that AC lie on omega 1, BD lie on omega 2, right? Okay. Let PQ be the perpendicular bisector of AB so that P and Q both are on first circle, that is omega 1, and CD has its own perpendicular bisector RS, right? So that again uh, uh, R and S are also on the second circle, and P and R lie on the same side of this line L, right? As you can see, line L as I marked here. So this line L, okay. Um, so we need to show that the midpoints of P and R, Q and S, and O1 O2 are collinear. Okay. So the thing is that, like, suppose let M be the midpoint of P and R, N is the midpoint of Q and S, and O is the midpoint of O1 and O2. Okay. So there's one thing to notice here. This line L is perpendicular to the perpendicular bisectors, right? The PQ and RS lines. So I mean, it's very comfortable for us to choose ABCD line as a x-axis for our coordinate system and the PQ line as a y-axis for the coordinate system. We can also choose R as the y-axis. You'll get the same answer. Okay. Or in fact, in general, you can choose any line that is parallel to either PQ or RS as your y-axis. Okay. Uh, so of course, suppose A has x coordinate as small a, B has x coordinate small b, C has x coordinate small c, and D has x coordinate small c. And x coordinate is called abscissa. Okay, so it means that the line PQ, which is the perpendicular bisector of AB, will have equation x equal to a plus b by 2, right? Because is a perpendicular bisector. Similarly, the line RS will have its equation as x equal to c plus d by 2, right? So as you can see here, x equals a plus b by 2 and x equals c plus d by 2. Okay. This means that the abscissa of P and Q are both equal to a plus b by 2 and the abscissa of R and S are both equal to c plus d by 2. Okay. Now, as we know, M is the midpoint of P and R. So M has abscissa. So abscissa of M is the average of abscissa of P and R, right? And P has abscissa A plus B by 2. R has abscissa C plus D by 2. So the abscissa of M is A plus B by 2 plus C plus D by 2 divided by 4, right? So M has abscissa A plus B plus C plus D whole divided by 4. I mean, you take the average. So it's very easy. Similarly, for N, even N has, I mean, Q and S have the same abscissa as P and R. So M and N end up having the same abscissa as A plus B plus C plus D upon 4. Okay. Now, now let's move on to the centers. Uh, O1, O1 is of course the center of the first circle, and we know that O1A equals O1C, right? So O1A equals O1C. So O1 actually lies on the perpendicular bisector of AC. So I mean, I'll just show the perpendicular bisector of AC right there. There you go. Similarly, O2 lies on the perpendicular bisector of BD. So as you can see, O2 lies on the perpendicular bisector of BD. And so the abscissa of O1 will be the average of the abscissa of A and C, right? Because it lies on the perpendicular bisector. So O1 has abscissa A plus C by 2, as you can see there. And O2 has abscissa B plus D upon 2, right? So the midpoint of O1 and O2 has abscissa that has abscissa which is average of A plus C by 2 and B plus D by 2, which is A plus C by 2 plus B plus D by 2 whole divided by 4, which is of course A plus B plus C plus D divided by 4. And it means that M, O, N, all these 3 points have abscissa A plus B plus C plus D upon 4, and that is also the required line. So you can see this line in the middle, like the middle line, is actually the answer, like the line. And this proves that the 3 points are collinear, right? Because they lie on a line. And also proves that this line is actually perpendicular to the original line L, right? So that is because any line which has a look of x equal to some constant will be perpendicular to the x-axis, right? So this proves the result, and this also proves one extra small thing which we have right there, and that pretty much proves the problem. The main idea in this question is not to get intimidated by the too many number of points that they have asked, because this is an RMO question, so they will try to intimidate you. But as you see, it's a very simple application of coordinate geometry. You can also think of this using midpoint theorem or using midlines of trapeziums. So if you consider the quadrilateral PQRS, uh, wait, I'll just draw that for you. So PQRS, so that is actually a trapezium, right? And I mean PQSR is a trapezium, and MN is actually the midpoint of this trapezium. And as you see, the midline of this trapezium is line MN, and O lies on this midline. So you can use some reasoning along with some length computations to show that O actually lies on the line MN. And I think that pretty much proves the problem. And yeah, we are done. And if you'd like to submit any other generalizations or any other variations to this problem, there are many variations which exist, and I mean, I'll leave it open for you all to explore. uh, then please do let me know. You can comment in the comment section, like and share the video, subscribe to my channel, and share it with your friends who want to prepare for Maths Olympiad this year and next year as well. Thank you.